you can not only configure the observe mode here, you can also configure the response type. The default here is JSON, which means the response data, so the data in the body of your response is JSON. And that tells Angular that it should automatically parse it and convert it to a JavaScript object. You could, however, also tell Angular, the response type will be text and please keep it as text. Don't try to convert it to a JavaScript object. It could also be a blob if it is a file, for example. The official docs, of course, are the place where you can learn all about all available response types. So if we use text here, and I add a new post here, whoops, send it first, then you still see, of course, that I get null here, because we had null before, and even if this is interpreted as a text, it still prints null. However, you can clearly see it is treated as a text, because it is now wrapped in quotation marks. Before, it was treated as the null object that exists in JavaScript. It becomes even clearer if we try using that here when we get posts. There, if I switch the response type to text, we'll see that our application even breaks, because it won't work if we try to work with a text response. And I even get an error here, because I am using that generic assignment here, and I'm saying, hey, the data that is returned here is actually of type JavaScript object that in the end holds a nested post. Well, TypeScript is smart and detects, well, if you tell me that my response data will be of that format, then it needs to be convertible to a JavaScript object. If you then also tell me that the response type down there is text, then you have to be lying somewhere, because it can't be both. It can't be a string, which is simply not in that format, and such a JavaScript object at the same time. So to make this work, we would have to get rid of that generic type assignment, and now we are allowed to save this. And now, of course, you see this breaks here. If I try sending a post and I fetch my post, it breaks, and I just see these lines, because my response here is in the end now treated as a text and not as a JavaScript object. And actually here it even breaks because the way I try to handle this is not correct. So I will revert this, and I will revert this back to JSON, which is the correct data type, which now works. But it is important to also be aware of this option, which you can use to tell Angular in case you are really getting back some text and you don't want Angular to parse it to a JavaScript object, or maybe you are getting back JSON, but you still don't want to let Angular parse it because you want to parse it on your own at a later point of time or anything like that. For this, you can set the response type. The default is JSON, and most of the time, like in probably 99% of all cases, this is the type you want to keep. So typically, you don't need to override that. We're nearing the end, but I won't leave this module without touching on one very important and very useful concept or feature that is also supported by the Angular HTTP client. And that would be interest setters. Now, what are interest setters? We're sending our HTTP requests here, and whenever we want to configure something like search params, we're doing this on a per request basis. And oftentimes, this is the way it should be because every request might need different headers. But let's imagine we want to attach this custom header to all our outgoing requests. And a more realistic scenario would be that you want to authenticate your user and you need to add a certain param or a certain header to every outgoing request, therefore, so that the backend can read that. You don't want to manually configure every request because that is very cumbersome. And for that, you can add interest setters. Now, how do interest setters work though? Let's create a new interest setter by adding a new file, and I will name this the auth interest setter because I kind of want to simulate that we dare attach some header to every request that is required for authentication on our backend. Of course, we're not really using authorization here, but that's just an example. So here I will add a file and I'll name it auth-intersetter.ts or auth-intersetter.service because it actually is basically an Angular service. And in there, you create such an interest setter by exporting a class, and you give that a name which, well, probably should be auth-intersetter service. You can name it however you want, but I will keep that general file naming convention, which we also used in the rest of the course. And this will implement a certain interface, and that is the HTTP intersetter interface, which you need to import from @angular/common/HTTP. Now, this interface forces us to add an interset method. And that interset method here will actually get 2 arguments. And it will get that automatically by Angular when it applies our intersetter. And I'll show you how to apply it in just a second. So here we get 2 arguments, and the first one is a request object, which is of type HTTP request, which you need to import from @angular/common/HTTP as well. This is a generic type, a generic object, so you can use the angle brackets to basically inform Angular about the kind of data this request will yield. And I want to write a generic intersetter here, so I will use any, because this will work for any data that might be retrieved by a request. And you have a second argument which is passed to interset, and that is typically called next. You could, of course, rename these arguments, but the first one is a request object, so rec makes sense. And this is a function which will forward the request, because the intersetter will basically run code before your request leaves your app, so before it really is sent, and right before the response is forwarded to subscribe. So it steps into that request flow, and next is a function you need to call to let the request continue its journey. But more on that in a second too. Next is of type HTTP handler, which also needs to be imported from @angular-common-HTTP. Now this interset method now allows us to run code that, as I just mentioned, will run right before the request leaves our application. So for example here, we could for now just log request is on its way. And thereafter we should return the result that next yields us. Next, as I mentioned, is a function, or actually an object, but an object with an important method that will allow us to let the request continue its journey. To be precise, that's the handle method, which you have to call, to which you should pass that request object. And by calling this, you let the request continue, and you should actually return the result to really let it continue. So that is the setup you need to use to have some code that is run right before the request leaves the app, and to still let the request leave the app. If you don't return next handle and pass the request, then the request will not continue, and therefore your app will basically break. You definitely have to return this here. Now, with that, we have to provide that service, and we have to provide this in a special way. So let's go to the app module, and in there, add a new element to the providers array. And that should be a JavaScript object now, and not the name of that service, where you have 3 keys. The first key is the provide key, and there you have to use HTTP_intersetters, all capital cases. That is a type that is imported from @angular/common/HTTP. So import that from this package and use it here as a value for provide. This is the token by which this injection can later be identified by Angular. So it will basically know that all the classes you provide on that token, so by using that identifier, should be treated as HTTP intersetters and should therefore run their intercept method whenever a request leaves the application. The second key you pass to that object is the use class key, where you now point at your intersetter class you wanna add as an intersetter. And here that would be the auth intersetter service, which you of course also need to import. And last but not least, you can have more than one intersetter, and you inform Angular about that, and that it should not replace the existing intersetters with this one by adding multi and setting this to true. So this is just a dependency injection syntax supported by Angular that allows us to register a service under a different identifier and to have actually multiple services under that identifier, which will then all be provided and injected. Now Angular will do the rest. It will automatically grab all your HTTP intersetters and run their interset method whenever a request leaves the application. And therefore, with this setup, we should now be able to reload. And we see request is on its way. And if I click fetch posts, you see it again. And if I send a different request, like sending a new post, you see it too, because this code now runs for every request that leaves the app. And if you want to restrict the requests for which this executes, you have to do that here in the intersetter. You got that request object in the end, and that request object has information like the URL to which it's sent. So if you know you don't want to send this to a certain URL, well, then you can use the URL here in a if check and compare it and so on. So you can control that all in here in the intersetter. Inside of an intersetter, you can not only log data, you can also modify the request object. However, the request object itself is immutable. So you can't set request URL to a new URL. That will not work, and you also get an error here. Instead, if you want to modify the request, you have to create a new one, like modified request, sounds like a fitting name for the constant, where you call request clone. And inside of clone, you pass in a JavaScript object where you now can override all the core things. You could set a new URL here, or you could add new headers. If you want to keep the old headers, by the way, then you simply do that by using the request headers and calling append, or you add new params or whatever you want. Now, I wanted to add a header here, so indeed I will access my headers, and I will access the old headers on the original request object, and then simply call append. And as you learned, this will return a new headers object, where I then have all the old headers, but also the new headers. And these will then be set here as headers for this modified request. And here I'll have my auth key, let's say, with XYZ as a value. Of course, this is just some made up header, which doesn't really do anything. And now the important thing here is I do not forward the original request, but my modified request. And that, of course, is a typical use case for an intersetter. You change the request and then you forward that modified request. And if you only wanted to append the auth header for certain URLs, then you could use a if check with the request URL key, for example. Here I will indeed log request URL so that we really see for which request the intersetter ran. And now let's go back and let's fetch some posts, for example. You see the URL is being logged. If we have a look at the network, fetch again, we inspect that request, you see that there on the request headers, auth XYZ was indeed added. And we should see the same if I now add a post. There, if we have a look at the request headers, we also see this. So our intersetter is adding that for all outgoing requests. And therefore, intersetters are a super important and useful feature.